So clear? Class? Okay?
Clear.
Clear. Okay. So I need to have keep interaction with you to ensure my network is good Otherwise I'm worried I talk alone because our connection already disrupted or terminated somehow. So you can ask through chat or you can raise your hand now Okay. So just an overview on this, continuing on this subject. So we just completed the few subject with Dr. Muhajir, anti-demand forecasting. So we are here now. So we continue with me. Start from linear programming, which is today before the 5th. Okay. So until week 15. So probably 9 July I mean, our last class. F7 is as per schedule However, it will be amendment or adjustment subject to time and whatever reason Okay, so basically I'm practice as a professional engineer. My company working in Petaling Jaya. So mostly my current project involved with this project. Construction, MAE construction in detail. So currently I involved with this highest building in Malaysia, PMB 118. Also mixed development like KL Eco City, Bukit Bintang BBCC Bukit Bintang City Centre just completed completed last year and open to public. Then you can visit. And then there is so at this moment we are focusing to deliver this PMB 118 So like I say, you can seek an advice from me with regard to this career development or any related engineering engineering matters in general not on the theoretically. So that one you need to refer with the relevant lecturer So in terms of construction, then I can advise you in general. But you can go detail if you have time to allocate. So just is it your last semester or you have another semester after this?
Last semester.
This is your last semester. Oh, okay, good. So you are be entering a career life after this. Okay. So in general, this topic is a non-technical compared to your core subject like fault calculation, power control. So it's a quite important because this topic, this subject the objective, you want to give some idea to the student when you enter to your career time or you looking. This is for example if we talk about our topic so we introduce you with the operation management. So concept productivity. I mean your course is a mechatronic Bachelor of Mechatronic Engineering. So generally you will involve with the manufacturing process. So when it comes to the manufacturing process, there is some standard you need to understand, like product quality, your operation management, performance. Okay, these are in general. But you will go deep during your career lah when you practicing this basic theory. Okay. So the topic under me subject will be cover linear programming, and then project management. So other than technical intake for your product, you should have project management team, project management guideline. So that as an engineer, beside your technical, the technical in terms of calculation, you should have on this project management background to managing the certain task project. So you have inventory management, JIT and lean operations, quality control, and maintenance management. Okay, then you continue. Okay. So under me, it will be one quiz, one quiz and one assignment. Okay. So take note, I will distribute the quiz and assignment soon as possible so you can plan. So I believe you guys also busy with your FYP2 since this is your last semester. Anyway, you need to allocate some time. You need to plan. As an engineer, after this, you need to plan your time. With your assignment, with your study, research, in order to meet your deliverable. Okay. So, straight away to our topic for today. Okay. Anyone, can you see my slide?
Yes, Doctor. Yes.
Okay. Okay. So, this is our first topic with me, linear programming. So, I'm using slide from Dr. Abdul Halim Ismail. Okay. So, what's the linear, what's the programming? Okay. Just to give some brief, when we mention a linear is a straight line. We have a linear and the versus with non-linear that you learn during your secondary school, I think, during your admin. So non-linear equation, which is parabolic or x power with 2, x power with 3. When talk about linear, you should remember this. Right? This is a linear equation. Okay, you have some background. Why you need to learn linear programming? Like I mentioned, you are bachelor in mechatronic, and mostly you will be involved with factory. So as an engineer, when you analyze something, you need to have a data before you solve any problem. So you need to you need to gather all these data or information before you propose the solution to your top management. Okay, we go one by one. History linear programming arose as a mathematical model developed during World War II to plan expenditures and returns in order to reduce costs to the army and increases losses to the enemy. So it was developed by George Danzig, mathematician. It was kept secret until 1947. So it soon became clear that surprisingly wide range of apparently unrelated to war problem, especially in engineering. So any problem or issue, we as an engineer should resolve. Like I mentioned, so after this, so during your career life, you will be dealing with your top management, and mostly your top management, their background, what, human resource, accountant, finance. So they don't know how to solve the problem. What, they just throw the problem to engineer. Like I mentioned. So as an engineer, you'll be able to solve a complicated problem. That's the difference between engineer and others. Complicated. So, engineer, you should solve. You can resolve, or you can solve all these complicated problem by equation or programming based on your understanding and your theory. To be specific, the manufacturing processes such as production management. Here's this course could be stated in linear programming terms. Put very informally, linear programming is about trying to get the best outcome. Example, maximum profit, least effort. So take note in this keyword, maximum profit. Where you dealing with the top management, definitely will ask you what's the maximum profit of this process, of this on this manufacturing process. When you add on this machine, is it can give a maximum profit? That's the favorite question from your top management. What's the ROI, return of investment? Can we maximize the profit by using this machine, this latest machine? Okay. But given some list of constraints. So you know, in current world we don't have any ideal solution. Want to increase something, and you need to sacrifice something. So there's the real world versus your ideal world. So if you want to increase something, let's say in terms of machine, if you want to increase the production, you need to add on your electricity bill. That's the constraint you need to consider. In this case, example, only working 30 hours a week, not doing anything illegal. So this is a constraint, 30 hours a week. This is depending on the certain country. Like in Malaysia now, we already revised to 48 hours a week. For 48 hours to 45 weeks now. This is your limit when you want to study the linear programming and doing anything illegal. You cannot use the same workers for 24 hours without race. That's one against the illegal, become illegal. So you need to consider the constraint. So you can model it using a linear mathematical model. Where is linear programming used? Most extensively is used in business and economic situation, but can also for engineering problem. So anyway, like I mentioned, engineer is not a robot, but engineer is a human that can solve the mathematical problem, the complex engineering, plus you should have some business background or economic background. You should know how to understand the ROI. So I hope you know what's the ROI. Anyone can answer me? What's the ROI? Just want to test the term.
Return on investment.
Okay, so definitely you know. You should know IRR or capital investment. All these are economic terms. Not simply highlighted or these are under finance department. These are under should be advised by accountant. You should know the at least basic how to calculate the ROI, how to make a differential between IRR 4%, 5%. So you can play the sensitivity on your capital investment. Some industry that use linear programming models, transportation, energy, telecommunication, manufacturing. It has proved useful in modeling diverse types of problems in planning, routine scheduling, and assignment and design. Okay, everyday example of linear programming. So JNT driver to deliver parcel to destination U, V, W, S, Y, and Z. So this company, this courier services, courier company, JNT, they try to model the linear programming. So they study from point A, from their warehouse or distribution center, so to U, W, X, Y, Z, individual housing. So the objective, least time as possible. So in order to maximize the profit, so they need to know, they need to study what's the least time as possible, least distance as possible, at the same time save fuel as much as possible. So they try to maximize the operation. Otherwise, their business cannot be sustainable. They cannot make a profit. If they cannot make a profit, they cannot offer a good salary to their staff. So there's this top management need to review and study. Ideal solution, choose the shortest path. So these generally they mention choose the shortest path. So how you as an engineer, how you want to resolve this instruction from your top management? So brute force computation take forever. I mean you need to solve one by one and required time to solve. So if you a smart engineer, then you can formulate this equation to some math model. If you are using this search computation, it become a try and error. You don't know which road is the optimum road. Is it A, U, W, Y? Or you start with A, V, X, going to U, W, and then back to Z. So it's a barriers. Then you need to create or formulate some math model. So the process of choosing the best route is called operation research. So you need to find the best route. Operation research is an approach to decision making which involves a set of methods to operate a system. So linear programming is used for obtaining the most optimal solution for a problem with given constraints. Remember, you should have a constraint. In linear programming, we formulate our real life problem into a mathematical model. So as an engineer, any problem, you need to convert it to the mathematical model so that you can resolve the problem with figure, number. So as an engineer, you cannot run with the number. You need to interpret the number to the value information. Very involved important parameters such as objective function, linear inequalities, which subject to constraint. Note, is the linear representation of object delivery example representative of the real world? Yes or no? We try to simplify by put a straight line. Is an oversimplification as the real route would not be a straight line. See? It will likely have multiple turns, U-turn, signal and traffic jam. This is a constraint you need to consider when you develop a mathematical model. But with a simple assumption, we have reduced the complexity of the problem drastically and are creating a solution that should work in most scenarios. So, whatever assumption you make, you should declare to your type management. Assuming due to the complexity of this scenario, you need to eliminate some problem, like say U-turn. U-turn because the speed of the lorry, let's say from 50, when come to U-turn, they need to drop from 40 to 20 km per hour. So this is a constraint with regard to time delivery. That's why we, in order to simplify the equation, we assume the route is a straight, or traffic jam. Okay, this is a light waste, So waste. So if it's a waste apps, that used for your go to any new any road there. This software, these apps help you to optimize the route. If you want to go to normal road, let's say required normal road, let's say 3 hours, but highway probably 1 and 5 hours, but subject to all fares. You as a user, you need to consider the toll fare. If I choose this normal road, it require 3 hours to reach your destination. But if you choose this highway route as proposed by Waze, it takes you 1.5 hour only. But of course, with the additional cost, which is toll fares, you need to consider. So these are example in your real life. Okay. So in order to understand this topic, so there's a common terminology that we use when we resolve this linear programming. Okay, decision variables. The decision variable are the variable that will decide the output. They represent the ultimate solution to solve any problem. We first need to identify the decision variables, normally stated as x and y. So you have a parameter x and parameter y. So objective function, it is defined as the objective of making decisions. A linear mathematical relationship describing an objective of problem required to be solved in terms of decision variables. The function to be maximized or minimized often denoted as z, as simple as z equal x plus y. So this is an objective function. And constraints. The constraints are the restriction or limitation or requirement on the decision variable. They usually limit the value of on the decision variable. So what's the limitation? Inwards. It's your limitation. Space area. Space. Because of this limitation, you need to, because it is space is one of your limit of your constraint, you need to consider as a constraint. So what's others? Working hours, space, working hours, how many hours? So we can explore lah after this. Non-negativity restriction. For all linear problems, the decision variable should always take non-negative values. This means the value for decision variable should be greater than or equal to 0. A non-negativity for linear problem lies of first quadrant. So in order to solve this linear program, so you have x, you have y. So you should solve during quadrant 1, first quadrant. So your x leading to positive, from 0 to positive, and your y also from 0 to positive numbers. So you cannot solve linear programming other than first quadrant. Okay. Okay, assumption in LP. Certainly, in all LP model, it assumes that all the model parameters such as availability of resources, profit or cost, contribution of a unit decision variable and consumption of resources. But a unit of decision variable must be known and constant. So you need to make sure the certainty in the constant value. So divisibility, the solution values of decision variable and resources are assumed to have either whole number or mixed numbers. However, if only integer variables are desired, then integer programming method may be employed. So additivity, the value of the objective function for the given value of decision variables and the total sum of resources used must be equal to the sum of the contributions, profit or cost, earned from each decision variable and sum of the resources used by each decision variable respectively. So the objective function is the direct sum of the individual contribution of the different variables. So linearity or relationships in the linear programming model, i.e. in both objective function and constraint, must be linear. Means that they are constant returns to scale and there are no economics of scale. Finite choices and LP model assume that number of choices available to the decision maker is limited and decision variable do not assume negative value. So your decision should be on the positive value. So this is a step you need to understand. Number one, you need to identify. We simplify this process. You need to identify the decision variables, write the objective function. Number three, identify the constraints. Number four, explicitly state the non-negativity restriction. So your x must be above 0 and y must be x equal and 0 equal okay, 0 let's say 5. So example 1. So now you are manufacturing chocolate. So consider a chocolate manufacturing company at Langkawi that produces only two types of chocolate. So you have a chocolate A and chocolate B. So both the chocolates required milk and cocoa only. The nature of each unit of chocolate A and chocolate B, the different quantity are required. So you need to identify the equation. Chocolate A required 1 unit of milk and 3 units of cocoa. And chocolate B, 1 unit of milk and 2 units of cocoa. So in order to produce, there's some formula we need to consider. Chocolate A and chocolate B. So probably chocolate A, they want to sell more expensive than chocolate B. So that's why they require 3 units of cocoa compared to B. There's a general understanding. The company kitchen has a total of 5 units of milk and 12 units of cocoa. Okay, so this is a limitation. They only have 5 units of milk and 12 units of cocoa. On each side, the company makes a profit of their target. Sorry? Oh, I thought you want to interrupt me with the question. Nothing, So I will continue. Okay, so their target to sold RM RM6 per unit chocolate A and RM5 per unit chocolate B. So definitely because they use 1 unit extra cocoa compared to chocolate B. So they want to this is a target. So the company wishes to maximize its profit. Then your management come to you. Based on this limitation and this target sale or target price, what the maximize profit we can make? How many of chocolate A and chocolate B should it produce respectively? So their management come to you as engineer. What's the maximized profit? Okay, first you need to table it. Chocolate A, you require amount of milk 1, amount of cocoa 3, and profit per unit RM6. And chocolate B 1 and amount of cocoa required 2. And their target of profit RM5 per unit. But we know the limitation. So total milk in the factory now we have 5 and 12. See? Let the total number of unit produced of chocolate A equal X. So they want to produce total number. Let the total number of Z unit produced of chocolate A is Y. Define the total profit in Z. So then you can convert to the linear equation. Therefore the profit is Z equals 6 RM6 times how many numbers you want to produce. Back to the equation. How many units? This why 6 times X plus 5 times Y. RM5. But we don't know how many numbers to get this the higher Z. So maximum profit is there, maximum Z equals 6S plus 5Y. So how do you want to solve this equation? We have a 2 variable X and Y. So how you want to resolve this equation? This equation means that we need to compute X and Y that could maximize Z. This is our objective function. Now let's identify the constraint. To produce both chocolate A and chocolate B, they require 1 unit of milk respectively. And we only have 5 units of them. So we have a 5 unit of them. Thus, x plus y should lower or equal than 5. This is our constraint. You cannot add milk more than 5 because we already know this limit. The limit is a 5 number of milk currently. There's the first limitation. And then to produce chocolate A and chocolate B, you need 3 numbers cocoa and 2 numbers cocoa. So what's the equation of the limit of equation? So 3x plus 2y must less or equal 12. So you have two limitation now, milk and cocoa. So how about a non-negativity? Like I mentioned, this equation should be resolved on the first quadrant. So your parameter x and y should be positive. X should be more than 0. X and y X and y. So chocolate should be always integers. Similarly for profit z, nobody wants a negative z. So what does negative z means? Therefore the inequality have to be satisfied. So you need to satisfy this, x equal or greater than 0, y equal or greater than 0. You need to test the equation. Okay. So now the chocolate manufacturing company at Langkawi finally can formulate is a LP problem. So you have to maximize z, the first equation, and then you have a limit in terms of milk, your constraint, and your chocolate, cocoa, the constraint, the limitation. Subject to with condition x must or least greater or must or same than 0 x and y. So now as an engineer you want to solve this equation by try and error. This is the first let's say you have a basic to resolve this linear, then you try to use this try and error. So you just put x1, y1, and then x2, y2. So you have a multiple numbers, multiple integer that need to be considered. Multiple number or integer that need to be calculated. So you have equation 1, 2, first scenario, second scenario, third scenario, and all possible combination. And this is a brute search, tire sum. So you put x0, y5, then you get this z25. But you don't know, is it 25 is the maximum profit? Then you try x1, then y4. So 26. So now this combination 1 and 4 is you can say is a more profit compared to first combination. But again, you need to consider another scenario. X equal to y equal 3. Then you found that this is become a highest profit compared the first and second scenario. This is the first, the second scenario. Then third, you have a third, 4, 5, 6, 7 that need to be considered, and its possible combination is a brute search tire sum. So how I want to solve this linear programming by graphical method? Graphical. So graphical method is a graph. You draw the line. Draw the line. Here's the idea. So previously we looked on how to formulate LP from a text problem into math equation, and we saw solution by brute search could take long time and not feasible. So nowadays firm and organization use a computer to solve it. Software such as SPSS, Excel, programming, OpenSolver, and more famously simplex method can be used. These are normally the normal software you model and solve, like your MATLAB, or whatever software simulated by others, invented by others. In this class, we will use graphical method in order to solve an LP problem. So other than real world, for this class, we just use this graphical method. Draw the line. In general, draw the lines and find the answer below the line. It's a general understanding why you need to propose this method, why you need to choose this. You need to draw the line and find the answer below the line. You will find this understanding after this. So this is another example. So example 1, example 2, you want to understand the equation, how to create the equation, and how to identify the problem or the limitation constraint. So to expedite this one, you know the limitation is a main days, and this is a net profit, and this is a cost. Okay, you need to identify the decision variable. So you convert. The first step, you need to table the parameter. So total area to grow width in hectare equal X. So total area to grow barley is Y. So is and then you write the objective function. Since the production from the entire land can be sold in the market, so the farmer would want to maximize the profit for his total produce. We are given net profit for both wheat and barley. From the table, the farmer earns a net profit of US$50 for each hectare of wheat and US$120 for each barley. Thus, our objective function is. So, okay, straight away identify 50x, 130y. So to maximize the profit, you need to identify x and y. But you need to know the limit, the constraint. Is it given that the farmer has a total budget of $10,000. So the cost of producing wheat and barley per hectare is also given to us. So equation become, so you know your limitation, 10,000, your cost. So 100x cost 100x plus 200y must below than 10,000. Must below or equal 10,000. So this is your first limit. Then what's the second limit? Your first limitation. Then should have a second limitation. First limitation is your cost, your modal. And second limitation is a main days. So in order to your staff, your workers to work to produce wheat, so you have a 10x plus 30y. Not much than 1,200. 1,200 is your unit is a main days. So the third constraint is the total area present for plantation. So the total available area is 110 hectares. So the equation become x plus y 1 to 10. So you have a two area. So first area x, second area y. So you need to draw the border. Then this is the equation, x. So that's the equation. So your total area not more than 110. This is your third limitation. See? It's not the ideal world. It's a real world. You need to consider this limitation. So the non-negative constraint, x must be above 0 and y, x and y, because you want to solve on the first quadrant. So the solution, so write down all equation, simplify where possible, plot the linear graph, feasible solution, intersection of the lines. So you want to find this maximum z, but this z subject to x and y. So what's the value of x and y? So we draw our first limitation, x plus y. This is our first equation. Your limitation is an area. And then second, x plus 2y, 100. This become, you simplify. 100 to 100. So you divide by 100. Okay. So you divide, you simplify the equation. Okay. So you divide by 100. Add this x. This one. 200 divided by 100, 2. And 10,000 divided by 100 is 100. So this is your first limitation. Straight away you can draw this line. How to draw? You should test. You put x0 and you can solve the value of y. And you put y equal to 0, then you get this value for x. And you can draw the line, your first limitation. And then your second limitation, x plus ty, 120. Okay. So maximum z value can be found based on this intersection. 50 times 60 plus 120 times 20. When you draw this line, this is the intersection. Okay. So basically this you already learned this graph during your secondary school. So I believe you can straight away understand. So I leave up this one, example 3, for you to do it after this. And I will leave with this some assignment after this, so that you can understand and you can submit. Okay, class. So we are reached 1 o'clock, and next is your lunch time. Okay, so this is a lecture for today. And if there any question or raise, you can ask now, or you can type through chat. But before that, please scan this your attendance for today. Okay. Can you see this one? The QR class?
Yes, Doctor, yes.
Yes,
Okay, so I give you about 5 minutes to scan the QR. Before we adjourn our class, Sorry. Here, okay. Okay. Is there any question you want to ask? You can WhatsApp me or you can email, or you can blast into group. And the slide will be show after this. I will share this slide through WhatsApp group. Okay. Assalamualaikum and thanks.
thank you, sir.
Okay.
Thank you, Doctor.
Okay. Don't forget to scan your
Okay.
attendance before you leave the class.